Download this code from codegive.com, link in the description below. Jonathan Blow is a well-known game designer and programmer, particularly recognized for his work on games like Braid and The Witness. While he is not primarily known as a security expert, he has contributed to discussions about software development practices, including safe coding practices that can mitigate buffer overflow vulnerabilities. Buffer overflows occur when a program writes more data to a block of memory, the buffer, than it can hold. This can lead to unexpected behavior, crashes, or security vulnerabilities, allowing attackers to execute arbitrary code. To mitigate buffer overflow risks, developers can adopt several strategies, which I'll explain along with code examples. Strategies to mitigate buffer overflow risks. 1. Use safe functions. Instead of using unsafe functions like strcpy, prefer safer counterparts like strncpy or snprintf. 2. Bounds checking. Always ensure that you check the boundaries of buffers before writing to them. 3. Dynamic memory allocation. Use dynamic memory allocation, example malloc in C, to allocate memory based on the input size. 4. Language features. Use language features that inherently protect against buffer overflows, such as containers in C++, like std vector or std string, or higher-level languages, like Python, Java, etc., that manage memory automatically. 5. Compiler protections. Enable compiler protections such as stack canaries, address space layout randomization, ASLR, and data execution prevention, DEP. 6. Static and dynamic analysis tools. Use tools to analyze code for potential vulnerabilities. Example of mitigating buffer overflow risks. Here's a simple C example demonstrating how to mitigate buffer overflow risks. Unsafe code example. C. Include sto.h. Include string.h. Void unsafe _copy, char * input. Char buffer 10. / potential buffer overflow. strcpy, buffer, input. Printf, buffer content, %s\n, buffer. Int main. Char * input equals this string is way too long. Unsafe _copy, input. Return 0. In the above code, if the input string exceeds the size of buffer, it will cause a buffer overflow, potentially leading to undefined behavior. Safe code example. C. Include sto.h. Include string.h. Void safe _copy, const char * input. Char buffer 10. / using strncpy to avoid buffer overflow. strncpy, buffer, input, size of, buffer, 1. / ensure null termination. Buffer size of, buffer, 1 equals \0. Printf, buffer content, %s\n, buffer. Int main. Char * input equals this string is way too long. Safe _copy, input. Return 0. Explanation. 1. Using strncpy, this function copies up to n characters from the source to the destination buffer. Here, we limit the copy to size of, buffer, 1 to leave space for the null terminator. To null termination, after copying, we explicitly set the last character of the buffer to \0 to ensure the string is null terminated, preventing any garbage data from being printed. 3. Input size awareness. By checking the size of the input against the buffer size, we avoid overflow situations. Conclusion. Mitigating buffer overflow risks is essential for writing secure software. By employing safe coding practices, using the right functions, and leveraging language features, developers can significantly reduce the chances of introducing vulnerabilities. Although Jonathan Blow may not be directly associated with security practices, the principles of safe coding are universally applicable across all programming disciplines, including game development.